Hello there, and welcome back to this quiet corner of the internet, where we believe that the most profound scientific discoveries are also the most soothing. This is the Sleepy Science Facts, and tonight we are continuing our gentle journey into the heart of the natural world. If you've drifted off with us before while exploring ancient trees or glowing oceans, welcome home. If this is your first time joining us, you've found a quiet place where busy minds can finally slow down and curiosity can lead you softly toward sleep. Tonight's exploration is inspired by 100 dreamy facts about nature, a collection of wonders designed to be both fascinating and deeply relaxing. We are looking for those quiet, profound truths, the scientific facts that remind us of the incredible patience, the vast scale, and the endless beauty of life on Earth. We won't rush. We'll simply let the facts unfold one by one, giving your mind a gentle anchor to hold onto as your body prepares for rest. Just before we begin our deep dive, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking this video, perhaps sharing your quiet thoughts in the comments, or even subscribing. Your presence here helps others find their way to this restful space, one sleepy soul at a time. Now, if your blankets are cozy, your light is dim, and you're ready to let your thoughts drift, let's begin with a secret sound the Earth has been making for a very long time. Our first secret is known as the Earth's hum. It is not a sound you can hear with your naked ear, but rather a continuous, low-frequency vibrational symphony that the planet produces all the time. Imagine the Earth not as a silent, stationary ball, but as a colossal bell that is gently, perpetually ringing. The hum is made up of waves that wrap around the planet, oscillating every few minutes. Scientists first theorized about this hum decades ago, but it wasn't officially measured until the mid-90s, when ultra-sensitive seismometers began to pick up on this constant, pervasive sound. It's too low for humans to detect, far below the range of normal hearing, but it is always there. This vibration is not caused by earthquakes or man-made noise. It is an intrinsic song of the planet itself, a permanent oscillation in its crust and mantle. The exact causes are still being debated, but many theories point to the continuous, gentle pressure of ocean waves battering the coastlines all around the world, or even the subtle movements of the atmosphere against the ground. Picture this: even now, as you lie quietly, the entire structure beneath you is vibrating, a monumental, silent pulse that has never stopped since the planet formed. It is a slow, steady, constant rhythm, a fundamental beat of nature that underlies all other sound, all motion, and all life. Let that feeling settle over you, the Earth, humming softly, a natural lullaby of immense scale, telling you that everything is fundamentally okay, in a rhythm far older than any human clock. This geological metronome, this invisible pulse, is perhaps the most fundamental and most relaxing fact of all. The world is still, and yet it moves, always, quietly, beneath us. It is the definition of stability in motion, the ultimate, endless background noise of the cosmos, a perfect fact to let your mind float upon as you begin to settle into the quiet of the night. The Earth's quiet, continuous hum is a lesson in monumental slowness, a reminder that the planet operates on a time scale far beyond our immediate experience. To continue our journey into the quiet rhythms of nature, let's leave the massive structure of the globe and descend into its deepest, coldest, and most patient realm, the abyssal ocean, where we find a creature that measures its existence not in years, but in millennia. This is the realm of the glass sponge, a life form that embodies slowness so completely it redefines the very concept of biological time. The most extraordinary example of this geological patience is a specific type of deep-sea sponge, often found in the frigid, dark waters of the Antarctic or the deep Pacific canyons. These organisms are not like the soft, commercial sponges we might know. They construct intricate, crystalline skeletons made of silica, which is essentially glass. This structure allows them to filter water with incredible efficiency in a food-poor environment. What is truly astonishing is their lifespan. While a giant redwood might live for a few thousand years and a massive whale for a couple of centuries, the oldest estimated age for a deep-sea glass sponge, determined by scientists analyzing their slow-growing structure, is over 11,000 years. This is a creature that began its life on the seabed before the construction of the Great Pyramids of Giza, before the invention of writing, living its entire, vast existence in silent, absolute darkness. Consider the pace of this life. In the extreme cold and the profound scarcity of nutrients in the deep sea, their metabolic rate is almost zero. They grow with an incredible, slow deliberation, often only expanding by fractions of a millimeter per year. Imagine a living thing growing at a rate so slow that if you were to watch it for a century, you might still not notice any visible change. This is a life lived in a state of nearly perfect equilibrium. The environment is stable, the temperature never changes, the pressure is constant, and the only motion is the slow, gentle current of the deep ocean. This lack of change removes the necessity for rapid adaptation, allowing for an astonishing, unparalleled longevity. The silica skeleton they build is not simply a support structure. It is an annual record of their endless existence. Scientists study the growth bands in their structures, much like rings in a tree, but these bands measure centuries, not seasons. Within the spicules, which are needle-like glass structures forming their bodies, the elements are added atom by tiny atom, a process of accumulation so patient that it forces us to reconsider the definition of life itself. The Monohaphis chuni, a glass sponge found in the deep waters of the East China Sea, is known to produce a single basal spicule, a crystalline anchor that can reach up to 3 meters in length. This single, pure glass needle, built by one creature, represents thousands of years of continuous, slow, and quiet work. It is a biological skyscraper erected in absolute darkness, the ultimate monument to patience. When you allow your mind to rest on this fact, let the slowness of the glass sponge become your own pace. Their lives are a testament to the fact that the most durable and persistent things in nature are often the quietest and the least hurried. There is no frantic rush in the abyssal zone, no stress to adapt quickly, only the steady, unhurried flow of time measured by the near-silent accumulation of a glass skeleton. This geological patience is profoundly soothing. It reminds us that our small, busy worries belong to a fleeting, accelerated pace, while the vast, silent majority of life on Earth operates with this quiet, deliberate, and ancient rhythm. Let your breathing slow to the pace of deep-sea growth, finding the stability in the quiet persistence of a creature that began its life in a world that modern humans can barely imagine. This is the ultimate lesson in being still, to grow and endure, not by fighting time, but by embracing its slowness. From the profound silence of the deep-sea sponge, we move to a quiet paradox found on the Earth's surface, the biomechanical stability of the humble tree. Specifically, let's consider the immense, self-regulating structure of the giant sequoia. These trees, the largest single-stem trees by volume on Earth, are not just colossal. They are living examples of nature's most effective long-term construction projects. A mature giant sequoia, which can reach heights well over 90 meters and a trunk diameter of over 8 meters, holds an incredible mass. The largest known individuals weigh more than 2,000 tons, the equivalent of over 1,000 cars, or the largest passenger jet. The question then is, how does such a massive, top-heavy structure remain standing, often for over 3,000 years, without collapsing under its own weight or being toppled by high winds? The answer lies in its biomechanical engineering, a study in natural stress distribution and self-healing resilience. Firstly, their root system is wide but surprisingly shallow, often extending out from the base for nearly 40 meters, creating a massive, stabilizing pedestal rather than a deep anchor. But this alone is not enough to secure such a weight. The true secret is in the taper and composition of the wood itself. The trunk of a sequoia is not a uniform cylinder. It tapers gently, distributing the immense weight and forces of the wind down the sides of the cone-shaped base, minimizing leverage. Furthermore, the wood of the sequoia is extraordinarily fire-resistant. Its bark is thick, spongy, and fibrous, often over 60 centimeters deep at the base. This bark contains natural tannins, making it difficult to ignite and protecting the vital internal tissues from all but the most catastrophic heat. Fire, in fact, is often essential for the sequoia's reproduction, opening its cones and clearing the underbrush for its seedlings, but the tree itself is designed to endure it. This resilience is not just passive protection, it's active self-repair. If a limb is damaged, the tree doesn't stop. It forms a callus, a thickened, healing tissue that slowly grows over the wound, compartmentalizing the injury and preventing the spread of decay. This process, known as compartmentalization of decay in trees coated, is a slow, steady, and successful biological strategy, allowing the tree to literally grow around its past traumas, reinforcing its structure over centuries. Imagine holding a personal record book of every storm you've ever weathered, not on a page, but in the fibers of your own enduring body, and using that record to become stronger. Finally, the sheer density of the wood provides an almost perfect structural material. It is strong enough to resist compression from its own massive weight and flexible enough to sway within safe limits in a gale force wind. This balance of strength and gentle flexibility is a profound lesson in stability. The giant sequoia stands not because it is perfectly rigid, but because it is perfectly integrated a vast system of roots, bark, wood, and crown, all working in quiet, structural harmony over 3,000 years. As you drift now, let your mind rest on the sheer, quiet stability of this immense tree. The sequoia is a monument to enduring strength that comes not from a frantic, hurried pace, but from patient, millimeter by millimeter construction and continuous, silent self-repair. It stands as a profound natural anchor, a reminder that the greatest strength is often found in the ability to withstand, to adapt slowly, and to keep growing quietly, season after patient season. Let its vast, unhurried presence ground your thoughts. We have felt the deep stability of the giant sequoia and the slow, profound rhythm of the earth's hum. Now, let's turn our attention to the air itself, not the storms and wind, but the quiet, essential cycle of moisture, which leads us to the surprising, self-generating climate of the Amazon rainforest. This fact explores how a forest becomes so vast and effective that it essentially creates its own weather system, known as biotic pump theory, or more poetically, flying rivers. The Amazon is the largest tropical rainforest on Earth, covering over 5.5 million square kilometers. It is often called the lungs of the world for its role in oxygen production, but its function as the Earth's greatest self-watering machine is equally, if not more, profound. The Amazon does not just respond to the climate, it dominates and generates it. The process begins with evapotranspiration. An estimated 20 billion tons of water vapor is released into the atmosphere every day from the rainforest through the tiny pores, or stomata, on the leaves of its billions of trees. This massive release of water vapor is greater than the daily discharge of the Amazon River itself. Imagine an invisible, immense, atmospheric river flowing above the canopy, composed entirely of water released by the living trees below. As this huge volume of moisture rises and cools, it forms enormous, dense clouds. These clouds do not simply drift away. They are often pulled by a system of air pressure differentials, the biotic pump that is sustained by the constant cycle of evaporation and condensation. The forest essentially sucks in moist air from the Atlantic Ocean and continuously cycles it inland, delivering rain hundreds of kilometers from the coast. The forest, therefore, waters itself. It is a closed-loop system of immense scale where the life of the forest feeds the clouds, and the clouds feed the life of the forest, sustaining the entire biome. When this weather system is disrupted, for example, by deforestation, the consequences are immediate and far-reaching. The loss of trees means less evapotranspiration, which leads to fewer clouds and less rainfall. This can cause a regional drying effect, potentially converting parts of the rainforest into dry savanna. Over time, the flying rivers are the most powerful evidence that all life is connected, demonstrating that the sheer mass of trees can exert a force so great it controls the very movements of the atmosphere and the distribution of rainfall across a continent. Allow your mind to picture this continuous, silent cycle, water moving from the soil through the root, up the trunk, into the leaf, and released as pure vapor back into the sky, only to return as rain. It is a perfect, self-sustaining loop, a living machine that generates its own existence, an act of creation that happens quietly every second of every day above millions of square miles of canopy. This fact offers a profoundly calming thought. The world is full of systems that renew themselves, that feed their own life, and that are far more resilient and interlinked than we often imagine. Let the thought of this constant, gentle, life-giving flow wash over you now, a reminder of nature's perfect, self-regulating patience. The Amazon's self-generated rain is a testament to life's ability to create and sustain its own perfect conditions. Now, let's move from the vast scale of the continent to the microscopic level of life itself, exploring the quiet, hidden infrastructure that allows certain deep-sea communities to thrive without a single ray of sunlight. This is the chemosynthetic ecosystem life, built on rock, heat, and pure chemistry. Most life on Earth is supported by photosynthesis, the process that converts sunlight into energy. But in the crushing darkness of the deep ocean, often miles below the surface, scientists discovered vibrant, thriving communities clustered around hydrothermal vents. These are fissures in the seabed where superheated, mineral-rich water, often reaching over 350 degrees Celsius, plumes out from the Earth's crust. Here, instead of using light, life uses chemosynthesis. The primary producers in this ecosystem, certain types of bacteria and archaea, don't capture photons. They capture the chemical energy contained within the compounds dissolved in the vent fluid, particularly hydrogen sulfide. This highly reactive chemical is toxic to almost all surface life, but for these deep-sea microbes, it is the fundamental fuel. The sheer volume of life supported by this chemical energy is astonishing. Around the vents, you find entire, densely packed ecosystems, massive colonies of giant, foot-long tube worms which have no mouth, gut, or eyes, but are instead sustained by symbiotic chemosynthetic bacteria living within them, pale white clams, blind shrimp, and enormous mussels. This is not a sparse, struggling existence. It is an explosion of life in the most unlikely of places, all powered by a purely chemical energy source, independent of the sun and existing under immense pressure and perpetual night. The key fact here, and the most relaxing one, is the perfect stability of this energy source. The sun rises and sets, seasons change, but the geological engine of the Earth, the movement of its tectonic plates, the heat of its core, is constant over massive time scales. The hydrothermal vents provide a continuous, unchanging flow of chemical energy, allowing the ecosystem to exist in a state of nearly perfect equilibrium. It is a slow, steady burn of Earth's internal heat, a quiet, endless fountain of life in the darkness. Picture these tube worms swaying gently in the hot, mineral-rich water, their red plumes colored by the hemoglobin that transports the necessary chemicals to the internal bacteria, the only splash of color in a world of deep blue and black. They don't worry about weather, predators, or the changing seasons. Their world is defined by the reliable, constant chemistry flowing from the planet's core. As you prepare to sleep, let this thought sink in. Even in the deepest, darkest, most extreme environment imaginable, life finds a way to not just survive, but to thrive, powered by a constant, non-solar energy source. The vast majority of the planet's heat and energy is internal, slow-moving, and absolutely dependable. This chemical anchor is a powerful symbol of quiet, enduring strength, a reminder that sustenance and growth are possible in ways we often overlook, found in the steady, patient unfolding of pure chemical processes. Let the thought of this ancient, quiet, deep-sea engine soothe your own systems to rest. We've contemplated the quiet strength found in the deepest, darkest realms of the ocean. Now, let's ascend and look toward the most profound source of life on Earth, the sun, and explore a fact about plants that simplifies their entire beautiful existence. This is the phenomenon of solar tracking and the concept of perfect energy harvesting as demonstrated by a common plant, the sunflower. The sunflower, Helianthus annus, gets its name from its remarkable habit of heliotropism, or following the sun's path across the sky throughout the day. What makes this a truly relaxing scientific fact is not just the movement itself, but the efficiency and quiet optimization it represents. In their budding and juvenile stages, young sunflowers track the sun precisely. They face east at dawn, slowly turn to follow the sun's arc until they are facing west at dusk, and then quietly reset themselves overnight, turning back to the east to await the sunrise. This perpetual, slow, synchronized movement maximizes the interception of solar radiation, increasing the overall light absorption by up to 30% compared to a fixed plant. This is pure biological efficiency, a natural, quiet algorithm for perfect energy capture. As they mature and their heavy flower heads open and set their seeds, they stop moving. the mature flower locks permanently into an east-facing position. This may seem counterintuitive, but it's another layer of optimization. An east-facing flower warms up faster in the morning sun, which scientists hypothesize attracts 5 times more pollinating insects in the early hours than west-facing ones. By the time the sun is high and hot, the mature flower is perfectly oriented to release its pollen and begin its reproductive work. The change in movement is a shift in purpose, from maximizing personal growth tracking the sun to maximizing the future of the species attracting pollinators early. The relaxing element here is the perfection of the cycle. This slow, constant movement is a symbol of quiet, perfect alignment with the Earth's rhythm. The plant is never frantic. It is simply always in the optimal position to receive what it needs most. This is a profound, non-verbal lesson in energy management. The sunflower spends no effort fighting the environment. Instead, it gently and continuously adjusts its position to be in complete harmony with the light that sustains it. Imagine the sunflower's quiet day, the slow millimeter by millimeter rotation, an unhurried, peaceful bowing to the source of all energy. It's a silent confirmation that when you align yourself perfectly with the source of your own nourishment, whether it's light, quiet, or rest, life becomes simpler and more abundant. Let the image of 1,000 sunflowers slowly turning their heads in unison become the quiet, guiding rhythm for your own breathing. They are the epitome of silent focus, dedicating their entire day to the single, simple task of absorbing light, a perfect, unhurried meditation on growth. The quiet efficiency of the sunflower's solar tracking shows us the power of simple alignment. Now, let's move our gaze from the perfect rhythm of the day to the subtle, slow-motion geology of the night, exploring a phenomenon that shows the immense, unhurried strength contained within the Earth's own skin, the tectonic plate movement, and its surprisingly gentle pace. We tend to associate plate tectonics with dramatic events, earthquakes, and volcanic eruptions. But these are just the momentary, rapid release of energy from a process that is, at its heart, incredibly slow and constant. The Earth's crust is fragmented into about a dozen major tectonic plates, massive, irregular slabs of solid rock that constantly float and drift atop the hotter, more ductile mantle beneath them. The key fact here is the rate of movement. Tectonic plates glide across the globe at an average speed comparable to the growth rate of a human fingernail, or roughly 2 to 10 centimeters per year. Imagine a vast continent moving at the speed of your most slow-growing tissue. This glacial pace is precisely why it is so relaxing. This is not the speed of a human life, but the pace of deep time. The plate carrying North America, for instance, is currently moving away from Europe at about the speed that a new strip of white grows at the base of your thumbnail over the course of a month. This slow, continuous, inaudible, and unstoppable movement has been the quiet architect of every mountain, every ocean basin, and every continent on Earth, shaping the world over billions of years. Consider the Himalayan mountains. This massive range, including Mount Everest, exists because the Indian plate is slowly, inexorably colliding with the Eurasian plate. The land is crumpling up where they meet. The entire process of the Indian subcontinent drifting north from its original position began about 70 million years ago, and the mountains are still growing quietly by a few millimeters each year. It is the ultimate slow-motion construction project. When you allow yourself to visualize this slow, gentle geological drift, it provides a powerful sense of quiet permanence. The Earth itself is a constantly shifting, but ultimately reliable mechanism, moving with an unhurried confidence that has defined the planet's surface. There is no rush in geology, only the steady, patient application of immense force over unimaginable stretches of time. This geological patience is deeply soothing. It reminds us that fundamental change doesn't require sudden, violent action. It often requires only continuous, quiet persistence. Lying still, you are resting on a surface that is perpetually, silently moving, yet feels completely stable. It is the definition of quiet progress, a reminder that the most significant transformations in nature are often the ones happening too slowly for us to perceive, unfolding with a majestic, unhurried pace beneath the very floor you rest upon. The Earth's tectonic drift is a masterclass in quiet, unstoppable momentum. Let's now transition from the unhurried movement of solid rock to the incredible, sustained power of a liquid phenomenon, the oceanic conveyor belt, or the thermohaline circulation. This is a massive, slow-moving current that connects all the world's oceans, acting as the planet's silent, deep-sea circulatory system. The oceanic conveyor belt is a global network of deep-sea currents driven not by wind, but by differences in temperature therma and salinity haline, hence the name thermohaline. This system is responsible for moving huge volumes of water, heat, and nutrients across the entire planet. The process begins primarily in the frigid North Atlantic Ocean. In the polar regions, surface water cools down significantly, and critically, when sea ice forms, the salt is rejected from the ice structure, making the remaining unfrozen water extremely cold and salty. Cold, salty water is very dense. Because of this density, this huge mass of water sinks to the ocean floor. Once this water sinks, it forms the deep water current, a slow, persistent river of cold water that creeps along the ocean floor, traveling all the way down the Atlantic, around Antarctica, and into the Pacific and Indian Oceans. This deep current moves at a pace of only a few centimeters per second, slower than a garden snail, but it transports enough water volume to fill the Amazon River 100 times over. The entire circuit is vast, taking an estimated 1,000 to 1,500 years for a single parcel of water to complete the full loop, from sinking in the North Atlantic to eventually warming up and rising back to the surface, upwelling in the Pacific and Indian Oceans, before flowing as a warmer surface current back to the Atlantic to begin the process again. The relaxing power of this fact lies in its vast, continuous, and steady nature. It is the definition of a closed, perfectly balanced system running on an immense geological clock. This slow circulation regulates the Earth's climate by transporting vast amounts of heat from the equator toward the poles. It keeps life thriving by cycling vital nutrients from the deep sea back up to the surface. It is a quiet, continuous, and reliable mechanism, sustaining the entire global ecosystem with an unhurried confidence. Imagine now, as you settle in, this slow, silent, cold river of water creeping along the deepest parts of the planet, an engine of global climate moving with a speed so slow it is the absolute antithesis of human hurry. This is the steady heartbeat of the ocean, a reminder that the world is sustained by forces that are patient, profound, and utterly predictable over millennia. Let the thought of this constant, slow, and powerful current move through your mind, carrying away any remaining agitation and settling your thoughts into the deep, quiet rhythm of the earth. We've explored the monumental, slow-moving currents of the deep ocean. Now, let's bring our focus back to the surface and contemplate the quiet infrastructure of the living world, turning our attention to the unsung heroes of communication, mycorrhizal fungi, and the incredible wood wide web. This is a profound biological fact that reveals the hidden cooperative intelligence of the forest. For decades, scientists viewed trees as solitary competitors, each fighting for its share of sunlight, water, and nutrients. The reality, however, is far more complex and far more serene. Beneath the forest floor exists an intricate, vast network of fungal filaments known as hyphae that form a symbiotic relationship with the roots of nearly all plants and trees. This relationship is called mycorrhiza, derived from the Greek words for fungus and root. The fungal filaments are incredibly fine, allowing them to penetrate soil far more effectively than a tree's root hairs can. The fungi act as a massive underground extension of the tree's root system, sometimes increasing the tree's effective absorptive surface area by hundreds of times. In return for this superior access to water and hard-to-reach nutrients like phosphorus and nitrogen, the trees, which are masters of photosynthesis, give the fungi essential carbon-based sugars that they have created from sunlight. It is a perfect, mutualistic exchange, but the most relaxing fact is the network's function as a silent communication and resource-sharing system. This interconnected structure allows trees of different species to share resources with one another. Larger, well-established trees, often called mother trees, can send carbon sugars to smaller, shaded seedlings that are struggling to photosynthesize enough light. They can also transfer defense signals to neighboring trees. If one tree is attacked by an insect, it can use the fungal network to send chemical warnings, alerting its neighbors to ramp up their own defensive chemical production before the danger reaches them. This wood wide web is not a system of competition, but a network of profound, quiet cooperation. It is a demonstration that the true success and stability of the forest biome lies in its deep, hidden connectivity and its ability to act as a single, massive, self-regulating superorganism. Picture the forest above as a bustling, individualistic world, and then picture the world beneath, a hidden infrastructure of dark, silent fibers through which carbon, water, and warnings are constantly and quietly exchanged. This hidden connectivity is an image of profound peace. It reassures us that even in the seemingly competitive environment of nature, the most powerful and enduring strategy is not isolation, but silent, steady support. Let the thought of this vast, cooperative network below your feet settle your own mind into a feeling of deep connection and quiet, mutual support. The quiet cooperation of the fungal network reminds us that life's greatest achievements are often collective. Our next peaceful fact takes us to the desert, a place of apparent barrenness, to reveal the incredible, patient strategy of survival employed by the resurrection plant. This fact shows how life can choose to wait for perfect conditions rather than struggle through drought. The resurrection plant, Selaginella lepidophylla, is a small, tumbleweed-like perennial plant native to the Chihuahuan Desert. Its survival strategy is not to adapt to dryness by storing vast amounts of water, but by entering a state of complete, extreme dormancy, known as anhydrobiosis, life without water. When the desert environment becomes unbearably dry, the plant performs a quiet act of self-preservation. It slowly, deliberately curls up its entire structure, its fronds and stems drawing inward to form a tight, gray, seemingly lifeless ball. This process minimizes the surface area exposed to the harsh, dry air, preventing the loss of the tiny bit of moisture remaining within its cells. In this state, the plant can lose over 95% of its internal water content, a loss that would instantly kill nearly every other form of plant life. It is not dead, it is simply waiting. The plant can remain in this dry, curled up state for years, or even decades, appearing as nothing more than a brittle, lifeless specimen of dried leaves. It survives by producing special sugars like trehalose, which stabilize its cellular structures, protecting its proteins and membranes from being destroyed as the water evaporates. It is a biological pause button, a complete halt to the processes of life. The true moment of wonder comes with the return of moisture. When the rare desert rain arrives, the plant, even if it has been dormant for years, can spring back to life. Within a matter of hours, the gray ball slowly begins to uncurl and spread its fronds, transforming into a vibrant, fern-like green plant, ready to quickly photosynthesize and reproduce before the brief, wet period ends. This quiet, rapid reanimation is one of the most compelling displays of life's resilience. The relaxing implication of the resurrection plant is its patience and its wisdom of rest. It teaches us that sometimes the most effective strategy for enduring difficult times is not to fight or to struggle, but simply to retreat, conserve, and wait. It knows when to spend its energy and when to enter a state of total, quiet rest until the conditions are perfectly aligned for flourishing. It is the ultimate natural reminder that deep rest is a form of powerful, necessary survival, and that the promise of renewal is held quietly within the stillness of our own dormant state. Let the thought of this quiet, waiting life bring a sense of deep, necessary peace to your mind. The resurrection plant's wisdom of deep rest is a tranquil reminder of cyclical renewal. To continue this journey into nature's quiet efficiency, let's explore a fact about the animal kingdom that is pure, profound energy management: the slow metabolism of the sloth. This creature is the living embodiment of anti-anxiety, teaching us the profound advantages of moving only when absolutely necessary. The three-toed sloth Bradipus genus is not lazy. It is merely an expert in energy conservation, a necessity dictated by its diet. Sloths primarily eat tree leaves, a food source that is notoriously low in nutritional content and difficult to digest. Because their food provides such little caloric energy, the sloth has evolved to have one of the slowest metabolisms of any non-hibernating mammal. Consider the speed of its life. A sloth moves so slowly that it often takes over a month for it to digest a single meal. This incredible digestive period requires a massive, complex, four-chambered stomach, much like a cow's, filled with specialized bacteria to break down the tough cellulose. Because digestion is such a long, low-energy process, everything else the sloth does is slowed down to match. The average top speed of a sloth is about 4 meters per minute, about 0.25 kilometers per hour. They spend nearly 90% of their lives hanging motionless from a branch. This extreme stillness is crucial for survival. By moving so slowly and infrequently, the sloth minimizes its energy expenditure, allowing its low-calorie diet to sustain its large body. Furthermore, this slowness has a side effect that adds another layer of quiet wonder. The sloth's fur often becomes a miniature, thriving ecosystem. Small moths and various insects live within it, and most famously, green algae often colonizes the sloth's coarse, specialized hairs, giving the animal a subtle green hue. This natural camouflage helps the sloth blend perfectly into the forest canopy, making it virtually invisible to predators like eagles and jaguars, which hunt by detecting movement. The sloth is literally defined by its stillness. The relaxing power of the sloth is in its absolute commitment to efficiency. It has found the perfect equilibrium between input and output, showing us that when energy is precious, stillness is the ultimate form of wisdom. It is a creature that has mastered the art of not moving, a living meditation on conservation. When you worry about the demands of the world, remember the sloth. It reminds us that rushing is often a waste of vital energy, and that slowness is not weakness, but a highly evolved, quiet strategy for long-term survival. Let the image of the sloth's perfect, unhurried pace bring a deep, resting slowness to your own thoughts. The sloth's gentle pace is a wonderful example of energy efficiency through rest. Let's shift our focus now to the quiet wisdom of light and color, exploring how a simple physical property of light creates one of nature's most perfect, tranquil phenomena, the blue hue of deep water. This is a visual fact that explains the quiet color of the ocean. We often imagine the ocean is blue because it is reflecting the sky. While the sky's reflection contributes to the color of surface water, the true, profound blue of deep, clear ocean water is a property of the water itself and how it interacts with sunlight. Sunlight is composed of a spectrum of colors, each corresponding to a different wavelength: red, orange, yellow, green, blue, indigo, and violet roigbiv. When sunlight hits the water molecules selectively absorb these different wavelengths of light. The longer wavelength colors, reds, oranges, and yellows, are absorbed very quickly and efficiently by the water molecules. This means that as light penetrates the ocean's surface, the red and orange colors are effectively filtered out within the first few meters. This is why, if you were to cut yourself deeply while swimming, your blood would appear green or even black just a few meters below the surface, because there are no red wavelengths left to reflect. The shorter wavelength colors, the blues and violets, are absorbed the least. Instead of being absorbed, the blue light is scattered back out by the water molecules in all directions. This scattering effect is what makes the deep ocean appear a vibrant, intense blue. The deeper the water, the more light absorption and scattering occurs, leading to that rich, pure, and uniform cobalt hue that seems to emanate from the water itself. This fact is profoundly relaxing because it reveals that the color of the deep sea is a matter of pure, unchanging physics. The ocean's blue is not a fleeting effect of the atmosphere. It is an intrinsic, quiet truth of its material composition. The deep blue color signifies a space where the busy, vibrant, and energetic reds and yellows of the surface world have been filtered out, leaving behind only the calm, cool, and steady blue wavelengths. Allow yourself to picture this quiet filtering process. As the light descends, the busy colors are gently, steadily removed, one by one, leaving only the tranquil, deep blue. This color is a natural symbol of depth, consistency, and quiet purification. The vast, unchanging blue of the deep ocean is a reminder that simplicity often remains when complexity is quietly filtered away. Let this pure, calm blue become the final, settling hue for your thoughts tonight. The pure, deep blue of the ocean is a quiet, visual anchor. For our penultimate fact, let's explore a fact about the most delicate yet resilient structures in nature: the snowflake's perfect symmetry. This is a profound, tranquil fact that highlights how simple, consistent physical laws lead to infinite beauty and variety. We all know the common saying that no two snowflakes are exactly alike. While this is likely true given the massive number of water molecules in a single flake and the near infinite combinations of temperature and humidity they encounter, the truly relaxing scientific fact is the reason for their six-sided hexagonal perfection. A snowflake begins as a tiny, supercooled water droplet freezing onto a dust particle in a cloud. The basic molecular structure of water is what dictates the snowflake's final shape. Water molecules $text H2 text of dollar naturally bond together in a way that minimizes energy, creating a crystalline lattice that is fundamentally hexagonal. This six-sided arrangement is the most efficient and stable way for the molecules to lock together. Every snowflake starts with this same quiet, six-fold blueprint. As the tiny ice crystal falls through the cloud, it is exposed to minute changes in temperature and humidity. It grows by attracting more water vapor, which freezes onto the crystal's edges. The fascinating, peaceful part is the consistent growth pattern. As new growth sprouts from one of the six corners, it slightly changes the airflow around the crystal. This change in airflow and vapor deposition is mirrored exactly on all six corresponding corners. This phenomenon, known as faceting, ensures that as one branch of the snowflake grows, its five symmetric partners grow identically at the same time. It is this delicate, continuous balance where every side is perfectly mirroring the conditions and growth of its neighbors that results in the exquisite, six-branched symmetry of a mature snowflake. The resulting diversity comes from the fact that no two snowflakes follow the exact same path through the sky, thus encountering a unique sequence of temperature and humidity changes. But the rule of symmetry is never broken. This fact is profoundly soothing. It reveals that perfection and variety are not opposites, but two sides of the same quiet, physical law. The snowflake's quiet, symmetrical growth reminds us that even under conditions of change and chaos, the tumbling through a stormy cloud, a deep, fundamental order and balance is being maintained. It is a moment-by-moment commitment to symmetry. Let the image of this quiet, slow, and perfectly balanced growth of a crystal bring a sense of pure, effortless order to your mind, settling your thoughts into a restful, six-sided calm. Our final fact brings us back from the quiet ecosystems of Earth to the most fundamental connection of all, a scientific truth that humbles and unifies everything we have discussed tonight. The cosmic origin of elements, or the simple, profound truth that we are stardust. Every atom of carbon in the giant sequoia, every molecule of iron in the deep-sea tube worm's blood, the silica in the glass sponge, the oxygen we breathe, and the very calcium in your bones. None of these elements were created on Earth. Our planet is a nursery, not a forge. These elements, which are heavier than hydrogen and helium, were created in the hearts of long-dead stars, in the intense heat and pressure of massive stars. A process known as stellar nucleosynthesis slowly fuses lighter elements into heavier ones. This patient process takes millions or billions of years. When these colossal stars reach the end of their lives, they explode in a magnificent event called a supernova. This cosmic explosion scatters the newly forged elements, the stardust, across the vastness of the galaxy. Our own solar system, including the Sun, Earth, and all life upon it, condensed from a massive cloud of gas, and this stellar debris over 4.6 billion years ago This is the most profoundly relaxing fact of all. It means that the material of your body, the atoms you are using to breathe right now, the atoms in the blanket covering you, traveled across the cosmos for billions of years before forming you. You are, quite literally, made from the same ancient, steady, quiet material that makes up the Earth's core and the distant nebulae, the tectonic plate that drifts at the speed of a fingernail, the water that cycles for 1,000 years in the oceanic conveyor belt, the slow chemical growth of the deep-sea ecosystem. All are structured by this same patient stellar matter. This understanding provides the ultimate sense of belonging and permanence. There is no separation between you and the nature we've explored. You are not just on Earth, you are of the stars that formed it. It is a unifying truth that connects the quietest human thought to the largest cosmic event, grounding you in a peace that transcends time. And now, our gentle journey through the hidden wonders of nature comes to a quiet close. We have wandered from the Earth's low hum to the tectonic drift, from the deep sea life to the sunflower's perfect alignment, discovering that life's most profound and enduring secrets are always found in its quietest rhythms. As you rest now, let your thoughts drift on the slow, unhurried pace we've explored. You might picture the immense patience of the glass sponge, accumulating glass atom by atom over millennia, or the silent, supporting web of the forest fungi. You can visualize the resurrection plant, curled up in perfect rest, waiting with absolute confidence for the moment of renewal. The world outside remains full of these quiet, patient wonders. They are always here, thriving, shifting, and holding their secrets until we take the time to look and listen. And the truth is, you don't have to go far to find them. The deepest, most enduring peace is often found in the simple recognition that you are an integral, ancient, and quietly persistent part of this immense, patient universe. Thank you for letting me share these moments with you tonight. If your eyes are heavy and your thoughts are drifting, you can let them go now. Nature will still be here when you wake, patient, timeless, and endlessly full of stories. Good night.